Hey everybody, welcome back to another math lesson. Today we're going to be moving on to exponential and logarithmic functions. So we're going to start off by doing lesson number 1, which is graphing and analyzing exponential functions. So let's get started. An exponential function is a function where the variable is an exponent. So with every other function you've dealt with so far, you've had whole numbers as your exponents, but now we're going to be moving into having the variable be the exponent this time. A base exponential function is written as y is equal to a to the power of x, where a needs to be greater than 0, and also a cannot equal 0. When the base value is greater than 1, the graph will result in an increasing exponential function, and when the base value is in between 0 and 1, the graph will result in a decreasing exponential function. So note, the function will change as we apply transformations to it. So we'll try example number 1. Sketch the graph of y is equal to 2 to the power of x. So one thing we need to note is that the base value is equal to 2. Okay, so we're just going to have x and y, and we'll have, let's just choose -2, -1, 0, 1, 2. Let's just try that. Okay, so if we have 2, so that's the base value, to the power of -2, well, that's equal to 1 over 4. And if we just do this completely throughout, so we're going to have 2's all the way down to the power of -1, to the power of 0, to the power of 1, to the power of 2. So the next one is the power of 1 over 2. And 2 to the power of 0, well, anything to the power of 0 will always give you the answer of 1. 2 to the power of 1 gives you 2. 2 to the power of 2 gives you 4. And so on. So this right here, this is an increasing exponential function. Okay. So let's go ahead and let's graph this out. So we're going to have just a couple lines here, just to space it out a bit. All right. We can see that if we're trying to find, we know where our y-intercept is. So our y-intercept is going to be where x is equal to 0. So that is at the value of 1. Okay, and then we found that, well, x is equal to 1. If when x is equal to 1, y is equal to 2. And when y is equal to 2, it's equal to 4. And it seems to be getting smaller and smaller. So you can see that the closer, or the more negative we get, the closer it gets to 0. Okay, but it actually doesn't equal 0, which means we need a horizontal intercept at y is equal to 0. Okay, so we're going to make sure that asymptote is continuous as well. Okay, so let's add a little bit of a note there to say that, yes, that is actually true. So for the x-intercept, which means that the y needs to be equal to 0. Well, if y is equal to 0, that means we have 2 to the power of x. And we need to ask ourselves, okay, what can x be to give me 0? And unfortunately, there is nothing in this case. So this is actually undefined, which means we have a horizontal asymptote at y is equal to 0. So that's why I threw in the y is equal to 0 there. We can see the trend in the pattern when we graph it out and just see that, okay, well, it's trending in this direction, which means it should get closer and closer to the value of 0, but in fact never reaches it. Okay, so that is example number 1. Example 2, so we're just going to keep rolling. Example number 2. Sketch the graph of y is equal to a half to the power of x. So again, for this one, we're going to say that the base for this one is 1 over 2. Which is still follows the criteria of us being greater than 0. Okay, so we're going to use the same values as before. We'll go x and y, and we'll go -2, -1, 0, 1, 2. Well, this one is going to be negative, or sorry, not negative. It's going to be 1 over 2. Okay, so 1 over 2 to the power of -2. And then I'm just going to keep filling it in. 1 over 2 to the power of -1, 1 over 2 to the power of 0, 1 over 2 to the power of 1, and 1 over 2 to the power of 2. Well, in this case, if we're going to go back up to the top, 1 over 2 to the power of negative 2 is actually, it gives you the value of 4. And 1/2 to the power of negative 1 gives us the value of 2. And anything to the power of 0 gives us 1. So it looks like we're trending in the opposite direction. So it looks like there's been a reflection, in this case, on the y-axis. So we can say that this is a decreasing exponential function, because it looks like it's going down and to the right. So in this case, again, if we're going to make our graph like so, it looks like we're trending in the decreasing section. So it goes 2, -4, 1 and 1. Oh, sorry, 1 and 2. My mistake. 1 and 2. 0, 1, and then 1.5, and then 1 1/4. So we are trending in the decreasing direction. So where we will still have a horizontal asymptote at y is equal to 0. Which brings us to now the properties of exponential functions. So from what you have seen so far, hopefully you can figure out that there are no zeros in this case. So there are no x-intercepts. So zeros again are x-intercepts, which means that there are none. Your function behavior, okay, so if your base is greater than 1, that means that it is increasing. Whereas if your base is in between, sorry, let me just rewrite that. If your base is in between 0 and 1, that means that your function behavior is actually going to be decreasing, as we saw in the first two examples. The first example being your base is 2, and the second example, your base is 1/2. Your y-intercepts, from what it would look like so far, is that it's always 1. Okay. Your equation of any asymptote, so in this case, for just regular base graphs, your equation is going to be y is equal 0. Okay, so it's going to be y is equal to 0. Your domain in this case can be any real number. So your domain can be anything. However, your range is going to be bigger than 0, not equal to 0, because we have a horizontal asymptote at y is equal to 0, which means our graph will never reach it, so that our range is going to be, everything is going to be bigger than 0. Okay? So, with that in mind, we are now going to do some transformations with this graph, with all these graphs to come. All right? So sketch y is equal to 2 to the power of negative x. So again, the base graph is going to be y is equal to 2 to the power of x. That's our base graph. So using mapping notation, as you've learned previously, in this case, all right, because it's to the power of negative x, this means that we are going to reflect over the y-axis. So that's what's going to happen. Okay? So let's go ahead and let's get us a couple points. So with that being said, if it's a reflection over the y-axis, that means it's going to be negative x and y for our mapping notation. So let's gather a couple points here. Let's do -1 and 1/2. Let's get 0 and 1, and finally 1 and 1/2, 1 and 2. Now, since we are now applying the transformation to it, we're going to do a reflection. So all of your negative x values will become positive values, and all your positive x values will now become negative. Okay, so you're just swapping signs. So it's going to be 1 and 1/2, and then 0 and 1, because 0, it doesn't matter, it's still 0. And finally, at -1, we will have the value of 2. Okay, so in this case, again, we'll map it out. 2, 3, 4, 1, 2, 3, 4, and finally 1, 2, 3, 4. Mapping it out again, we should get 1 and 2, so it should be in this order here, very similarly to before. Okay, so if you've noticed, actually, this particular graph looks very similar to y is equal to 1 over 2 to the power of x. Very similar to, okay? So note that y is equal to 2 to the power of negative x is the same as the equation y is equal to a half x, which makes sense because if you were to remember your exponential laws, you like your laws in that case, it'll be y is equal to 1 over 2 to the power of x, okay, for us to get rid of the negative for the exponent. So that's how that works. All right, let's try another example. So we have y is equal to 4 to the power of negative x plus 2. So the base graph is going to be y is equal to 4 to the power of x. So if we're going to gather 3 points from this one, let's use -1, 0, and 1 for our x values. Okay, so if it's going to be if x is going to be -1, that means our y value is going to be 1 over 4. And if it's going to be 0, then our value will be 1. And if our value is 4, or sorry, if our value for x is going to be 1, then the value is y value will be 4. So our mapping notation in this case, so how this is going to map out, if we have, and this is in brackets, so this is going to be -x plus 2. Because this is in brackets, you have to treat it as if that we're only moving for our x values. Okay, so we're going to take the -x. Okay, so you're going to do reflection on your y-axis and then add 2 to it. So it's going to be -x plus 2, and then we will leave our y values alone. Okay, so again, reflection first, and then you add 2. So now instead of it being at -1, it's now at 3 and 1 over 4. Instead of it being at 0, it's now at 2 and 1. And instead of it being at 1, it's now, oddly enough, also at 1. So in case that point does not move, which means we could say that that's going to be at an invariant point. All right, let's go ahead and let's graph this out. So we have 1, 2, 3, 4. All right, so if we were to graph this out, it should look something like this. So 1, 4, 2, and 1, and finally 3 and a quarter. So we're getting closer and closer to, but never reaching. So there you go. If I were to ask you, find me the y-intercept, you can go ahead, you can solve it like this. So we have the y-intercept, that's when your x is equal to 0. Okay, so we have y is equal to 4 to the power of 0 plus 2. Sorry, it'll be, I guess, -0 plus 2. Which again, -0 plus 2 will just be 4 to the power of 2, which is 16. So there you go. If there were a question that were to pop up in your problems were to say, hey, can you find me the y-intercept? That is how you would find it. Set x to 0 and solve. Okay, moving on. Example 5. So sketch y is equal to -2 plus 3 to the power of x plus 1. All right, so our base graph is going to be y is equal to 3 to the power of x. And we'll just choose our values again. So -1, 0, and 1. And we'll say this is 1 over 3, 1, and 3. Now, for how this is going to work, the -2 is going to affect your y values. Whereas the x plus 1, okay, so the x plus 1, that's going to be your x values, okay? So let's change our mapping notation to be x minus 1, and then y minus 2, okay? So remember, whenever it's in the brackets, we do what's opposite. Okay, so yes, it does say we have to add 1 there, but remember, when it's in the brackets, we do whatever is opposite of it, okay? So in this case, we're going to move it over 1. We're going to move it 1 to the left. Okay, we're going to take our x values and subtract 1 from it. So instead of it being at -1, it's now at -2. And we're going to subtract 2 more from our y values. So it's going to be -1 and 2/3, if you want to do a mixed fraction. And for the next one, our x value is going to be -1, and our y value will also be -1. And finally, we'll have 0. So in this case, we may have an x-intercept. That means we set y to 0. If we do that, then it's going to be equal to 3 to the power of x plus 1 minus 2. Okay, which means that if you were to move it over, it's going to be 2 is equal to 3 to the power of x plus 1. And in that case, this will come in a later lesson. So I will show you in a later lesson how to solve this. So I'm going to say stay tuned. But let's go ahead and let's graph this, okay? So we have all the points that are necessary. So it is going to be, let's see, 1, 2, 3, 4. So again, at -2, we have -1 2/3. And at -1, we have -1. And at 0, we have 1. So it looks like we're trending in this direction here. Because we also need to add in our horizontal asymptote, which is moved. So our horizontal asymptote is now at y is equal to -2. Okay, so our graph is going to be looking very similar to this. There you go. So that's how you do this one. Again, just a quick little recap. If everything outside of the brackets, so your bigger numbers in this case, so your constants, they will be they will affect your y values, whereas everything attached to the x, so in your exponential part, that'll be your x values. Okay. All right, let's move on to the next example. So we have y is equal to -2 to the power of x plus 4. Okay, so our base graph is going to be y is equal to 2 to the power of x, which is what we've seen before. So we have -1.5, 0 and 1, and finally 1 and 2. How this is going to map out, okay, because this negative is attached to the outside, so attached to the base of 2, we're going to say this is a reflection about the x-axis. And then you move up 4. So move up 4. Okay? All right. So let's do a mapping of that. So again, that's going to be leave your x values alone. And then you'll do a -y plus 4. Okay, so now it's going to be at -1 and 3.5 if you want to use decimals. And then it's going to be at 0 and 3. And then finally at 1 and 2. So let's go ahead and let's graph this. Okay, so remember that we are doing a reflection about the y-axis, about the x-axis. Okay, so our horizontal asymptote is going to change. It's going to be at 4. Okay, so it's going to be at y is equal to -4. Or sorry, y is equal to 4. Okay? So, that means our graph is going to be going in the opposite direction because we have a reflection on the x-axis. So it's going to be, again, at -1 and 3.5. Okay, and then we have 0 and 3. And then we have 1 and 2. So our graph is going to look something like this. Oops, I apologize for the drawing, but that is what it should roughly look like. Okay, all right. If we want to find our x-intercept, let's just take a quick pause here, because you're probably thinking, well, how did you know that the x-intercept is equal to 2? Well, if we're going to do it quickly, that's going to be 0 is equal to -2 to the power of x plus 4. That means that -4 is equal to -2 to the power of x. Since they're both negative, I can divide them both by -1. So now that's going to be 4 is equal to 2 to the power of x. Well, what times 2, right? 2 times something gives you 4, right? So it has to be itself at some point. So 4 can be rewritten as 2 to the power of 2 is equal to 2 to the power of x, which means x must be 2. So that's how we got that. Bit of examples. Okay. So now we're going to actually describe the transformations that's happening. Everything so far has been graphing everything and using mapping notation, but now some of your teachers may ask you to actually describe using words. I know, kind of scary, but I know you can do it. All right, so describe the transformations required to obtain the graph of y is equal to -2 to the power, or -2 times 2 to the power of x. Okay, so remember your base graph is y is equal to 2 to the power of x. So basically, by describing, you're just writing down what's happened. So in this case, you can see that there is a reflection. Now, because it's on the coefficient on the outside and not attached to your x, it's going to be a reflection over your x-axis, as it only affects your y values. And last bit, you have a vertical stretch by a factor of 2. So it's nice to actually split up, okay, the transformations that are happening. Yeah, it's all attached to the 2, so like the -2, like you can say it all in one go, but it's nice to actually separate them into the 2 steps. You can actually see what's going on. Okay. Example 10, determine the y-intercept of the function y is equal to 2 to the power of x minus 1. So in that case, again, you just set your x to 0, so it's y is equal to 2 to the power of 0 minus 1, which is y is equal to 2 to the power of -1. And finally, the last step, so we have the y-intercept is located at 1 over 2. Okay. Example 11. Okay, so determine the horizontal asymptote of the function y is equal to 3 to the power of x minus 1. So the only thing to take away is this part here, which means you're moving the entire graph down 1. So because you're moving the entire graph down 1, your horizontal asymptote will also move down 1, which means your horizontal asymptote will be at y is equal to -1. Again, that follows from your base graph being your horizontal asymptote being at 0. Move it down 1, now it's at -1. All right, last example. Okay, so it says determine the range of the function y is equal to -3 to the power of x. So if we have 3 to the power of x has a range of y is greater than 0, right? If we're going to do now -3 to the power of x in saying that, oh, well, wait a minute, this is a reflection over the x-axis. And because of that, this will have a range of y is less than 0. That's your answer. Okay. That is it for today's lesson. I hope you enjoyed it. So until next time, remember, when it comes to math, keep calm.